All right, everybody, today's new lesson is on similar and congruent figures. So getting into a little bit of geometry here, but a couple words here that we're going to talk about right away, what it means for figures to be similar and what it means for figures to be congruent. So the first one that we have here is what congruent means. Okay, it says congruent are figures that are exactly the same shape and the same size. So basically congruent means that they're exactly equal. Matter of fact, we can even write this here. It means that they're equal. They're exactly the same. Nothing's different about them. So if I were to draw two triangles here, and I know I'm drawing it, so that might not be perfect, but if I draw two things that are the same shape and the same size, and I can label this this is triangle ABC, and let's call this one triangle XYZ. But if they're exactly the same shape and exactly the same size, that's what it means to be congruent. Now, the way that we write that is I would simply say this. I would say, I'll make a little triangle there, so I can say triangle ABC is congruent to. Now, the symbol for is congruent to is this little equal sign with the squiggly line over the top of it. This is the congruent symbol, and it means that they're exactly the same. So triangle ABC is congruent to triangle X, Y, and Z. Okay? So, but we got to know what that symbol means. It means that they're congruent. So it means that everything is exactly the same. All the sides are the same. All the angles are the same. Okay? Then when we get down to this next one here, similar. Well, similar means, well, they're kind of the same, but not exactly. Okay? These things are similar. Okay? So that's what it says here for a definition. Figures that have the same shape, but not necessarily the same size. So same shape, how about if I do something like this? Okay, make a triangle going this way, same shape, not necessarily the same size. It just means, well, one might be smaller than the other. They pretty much look the same. It's just that one, is a little bit bigger than the other. So if I call this one, again, we'll just call it A, B, C to be simple, and we'll call this one X, Y, Z. And what we say there then, the symbol for similar is just that little squiggly line. So I would say, again, triangle ABC is similar to triangle XYZ in this case, where this time just a little squiggly line. We don't have the equal sign there. Just a little squiggly line means is similar to. Okay? And then, of course, I'll just draw off to the side here one last thing here. If we have shapes that are not the same shape, then of course they're not going to be congruent or similar. So I could do something like this, or I have a triangle here, then let's say I have a different kind of a triangle this way. Okay, those clearly do not look the same. They're not the same shape at all. So these are not similar, okay, if they're different. The last thing I have on this page that I want to point out is way down at the bottom here. It says corresponding parts. Okay? Corresponding parts are the pieces that match up. It says sides or angles that have the same relative position. So if I look back up here at these two right here, okay, let's go back up here and just examine these two triangles, okay? The same relative position. So if I'm talking about angle A, okay, which is this one right here, basically, if I'm talking about an angle, well, I want to know what angle is in the exact same location over on the other one. Well, you can find it easy enough that A is going to match up with X. If I picked up triangle ABC and set it right on top of triangle XYZ, the A and the X would match up. Now, you can tell really easily on these because those shapes look exactly the same. But the one kind of key that I want you to get you to look at is this. Notice over here, when I said that they were congruent, A is the first letter that's listed. Guess what? Over here, X is also the first number that's listed. Okay? That's how I know that B is going to match up with Y, because right here, B is the one that's in the middle, and over here, Y is the one that's in the middle. So B and Y are what we call corresponding angles. And then, of course, we have a third set. We have C and Z that will go together, because C is the third one, and Z is the third one. So you're kind of matching up the different parts. And it's the same thing with sides here. Okay, and I know this is getting a little messy, but with sides here, if I'm looking at side BC, which would be this side of the triangle here, I want to say what side that matches up with over there. Well, let's go ahead and look at the label where I said they're congruent. B and C is the second and third letter. The second and third letter on the other one is Y and Z. So I know that B and C matches up with Y and Z. Okay? So corresponding parts are parts from one, either sides or angles, that match up with the sides or parts from either the similar or congruent figure that we're talking about. Okay? Okay, properties of similar figures. So now we're going to start to talk about these corresponding parts a little bit here. So I have my little figure over here that we're going to use to do these two things. Don't want to leave the D out there. So there's the picture. There's the problem that we're looking at. Okay, it says properties of similar figures. These are two rules that if I know things are similar, these two things are true no matter what. Okay, and I know these two things are similar, even though they might not look like it because I drew it, but I know they're similar because we're told they're similar right there. They told us by giving us that is similar sign, they're telling us these two things are similar. So I know number one and number two, these two properties are going to be true. Rule number one, it says corresponding angles are congruent. Okay, corresponding angles are congruent. So what that means is this. If I'm looking at angle A here, so here's A, that would be this angle inside of it, okay? Angle A, and that's what that little symbol in front of the A means. It means angle, okay? Angle A is going to be congruent to the angle on the other triangle that it matches up with. But again, rather than just kind of looking at position in the figures, what I like to do is I want to go up here. I want to go up here to where they tell me the two things are similar. And I look, if I'm talking about A, well, A is the first one listed. So I know it matches with the one that's listed first on the other triangle, which was D. So angle A is going to be similar to, or not similar to, angle A is going to be congruent to angle D. So if I knew how big angle A was, if it was 60 degrees, I would also know that D is 60 degrees. They're going to be the exact same angle. Now, what I have to do this is match up all the parts. So not only does angle A match angle D, but I got to also do angle B, and I've also got to do angle C. I've got to do all of these and figure out which ones they're congruent to on the other triangle. Okay, well, B is listed second right here. Okay, and E is listed second, so B and angle E go together. And then finally that leaves me with angle C matches up with angle F, because those are all listed third in that picture up there. Okay. Now, part number two, the ratios of lengths of corresponding sides are equal. So here's what that means. We've been talking about ratios lately. What they're saying is, and I'm going to rewrite this, rewrite up above where I said they were similar. I'm going to rewrite what it says. It's triangle A, B, C is similar to triangle D, E, and F. Okay? Now, when it's talking about the ratios of the length of side, well, we're talking about ratios. So I'm going to write a ratio. So there's my fraction bar. And if I start with one of the sides, like side A, B on the first triangle, okay? Well, it's going to be in a ratio with its corresponding side from the other triangle. So I need to look here. A, B is the letters that are listed first and second. So on the other triangle, it's D, E. So A, B goes to D, E. Okay. Now, it's saying the ratios of lengths of corresponding sides are equal. So that means whatever that ratio is, it's going to equal whatever the other sides are. Okay? So, I already used AB, so I got to pick another side. Let's try BC. Okay, side BC. It's going to match up with its corresponding on the other one. Well, B and C is the second and third, and over here the second and third is EF. So BC and EF go together, so they make a ratio. And then that's also going to be the same as the third side that we haven't used yet. So again, I've used AB already. I've used BC. The only side I haven't done yet is AC. Okay? So I look at AC. Well, AC was listed, that was the first letter and the third letter. So the first and the third on the other one is D and F. So AC goes with D, F. Okay? So those three ratios had better be the exact same thing. So let's go ahead and plug the numbers in and see if it actually works out. So AB is 4 units long, and that's going to be over DE, which is 8 units long. Well, I know 4 over 8 is a half, so that's cool. Okay, BC goes with EF. Well, BC is 3 over EF. Well, EF is 6. Well, guess what? 3 over 6 also equals a half. Okay, let's try to make sure that the third one is the same. It should be. AC is 5 units long, and that's going to be over its corresponding side, DF, which is 10 units long. And guess what? 5 over 10. All three of these things are equal. That's going to be true every single time that we have things that are similar. So what's the ratio of the lengths? Well, we would reduce these all and say that the ratio of corresponding sides is 1/2, because that's what they all reduce to. They're all the same. Okay? If for some reason when we found those three ratios, if one of them was different, if two of them ended up being a half and the other one ended up being 2/3, then that proves to us that the figures actually are not similar. In this case, all three ended up being a half, so they are similar. Okay, let's move on. I got one last one for you guys here. Okay, this is exactly what we just did with the corresponding sides, the ratios of the lengths. It says example 1, given that ABCD is similar to JKLM, find the ratio of lengths of corresponding sides. Okay, so you're going to do exactly what we just did. Okay, so go ahead, pause the video, try to come up with what the ratio should be. Okay, if you're back, trying to find the ratio. Now, here's what I know. The directions here are telling me absolutely for sure that these two things are similar. Okay, because they're telling me that they're similar, I know that all of the ratios of the sides are the same. So even though there are 4 sides on these, I don't have to find 4 ratios. All I have to do is pick one. So I'm going to pick one side like AB. Okay, and then I have to find the side that's corresponding with AB. Well, since AB is the first 2 letters, the first 2 in the other ones is JK. So JK goes with AB. Now let's plug in our numbers. Okay, I know that AB is 8 units long, and JK is 12 units long, and then all we need to do is reduce that. So let's divide these both by 4, then we're going to get 2/3, and that is the ratio of corresponding sides. I don't need to find all the other 3 sides ratios. I know that they're going to be exactly the same thing. They're going to be 2/3 because I already was told that they were similar. Okay, so they're already telling me that those rules are going to be true. Okay, so good luck. That's our lesson for today.